Okay, basic cosine, basic sine. Numbers in front change our amplitude. And I'm going to just use sine, but cosine can work here as well. If I put something in front of my angle, they use theta, so I'm going to continue with theta. If I put something in front of my angle, theta, that changes the period of the graph. But then, if I add something to that angle, that's going to shift my graph left or right. And if I add something to the end, it's going to shift my graph up or down. And so A equals the amplitude. Remember, I should be more specific. Absolute value of A equals the amplitude. For cosine and sine, if I put 2 pi over B, I'll get the period. The opposite of C over B is the phase shift. Or the horizontal shift. Essentially, that, I'm just going to add that in a little bit of a different color here just so it stands out. We get this thing here by taking B theta plus C, setting it equal to 0, and then solving for theta. That's how we get the opposite, and hopefully you can visualize. I would subtract the C and divide by the B. So that gives me my phase shift. And then lastly, the D gives me my vertical shift. Now when we start messing with the phase shift and the vertical shift, it changes our approach a little bit. We can't really always jump in as quickly as we did before, draw the graph, make all the lines, and be done. We're going to have an adjusted axis for both of these. And so these are two things that need to be addressed before you start labeling anything, all right? So these are the last things we add, but the first things that we need to look at. I always do my shifted axis in green, and if you have another color, I recommend that you get another color out so that you can shift your axis and see where it is. It is important that when we graph, we see our original axis that we're graphing and our shifted axis that we're graphing, okay? So those are the two things that I want to see when you make your graph. When you start, it is always a little bit difficult to kind of think into the future because you're sort of acting like a machine and you're just doing what you're told. But once you get comfortable doing this, you need to kind of pay attention to what's going on. For example, when I find my phase shift, it is going to shift the graph to the right. And I know that because when I set this equal to 0, I will add the 11 pi over 6 to get my phase shift. And so when I make my graph, I want to keep that in mind. I want to make sure that I give myself enough room to the right on the graph. But before we get into that, let's find all of these pieces, okay? So what is the amplitude on this graph? 2. Excellent. What is the period on this graph? It is determined by the number in front of the angle. 2 pi. It's 2 pi over 1. There's no number in front of the angle, so it's 2 pi. Remember, that's what I'm looking at right there. Then I'm going to do my phase shift. And again, the phase shift is the opposite of C over B, but really what we're doing is we're taking theta minus 11 pi over 6 and setting it equal to 0. We're basically finding a new 0 for our axis. And so to solve, I would add 11 pi over 6. And so what that means is I am going to move to the right almost 2 pi. What's the crazy lady talking about? What does she mean, almost 2 pi?
12 over 6.
Yeah, 12 pi over 6 is 2 pi. This is 11 pi over 6, so it's just shy of 2 pi. So we're going to move 2 pi to the right. Well, if my period is 2 pi, I'm going to move this graph almost all the way over to where the end of the original graph would be. Okay? So I've got to keep that in mind. That's what I was saying before. Think about where your graph is going to go before you start drawing the coordinate plane that you're putting it on. Okay, so here is number 1, my amplitude. Number 2, my period. 3, my phase shift. 4 is my vertical shift. Is there anything at the end or at the beginning? No. So my vertical shift, there is none. All right? Now I'm going to put it all together. I've already used a lot of my work, so when I make my graph, I'm going to have to make things small. I'm going to make this really as long as I can. And knowing that my graph originally would repeat itself in 2 pi, and I have to move this to the right almost 2 pi, when I make my original tick marks that I'm going to label, I am just going to give myself, like, only take up half the room, because I'm going to have to extend this. But I'm going to label them. This is 2 pi. Halfway is pi. Pi over 2. 3 pi over 2. We didn't have any fancy math. I do not have a vertical shift, so I can label my amplitude right away, 2 and negative 2. And again, because I want to move this to the right almost 2 pi, that's where my green line comes into play. I have a new starting axis. And I'm going to just put my green, again, I have no vertical shift, so I can put my little green thing there. I need 4 tick marks, 1, 2, 3, 4, to complete my graph. And because this is cosine, I will put my cosine graph on that shifted spot. Cosine starts up. And there's my shifted cosine. Do you have to number this? No, you don't. You don't need to get into all the fraction mess that goes in with that. Too much of a headache. Just need to know where you shift and how much you shift. And then get your right graph on. Any questions on that? Doable? Okay. Let's move on. Another cosine graph. This graph is going to be shifted to the left. How do I know? Yeah, because this is a plus and I'm going to subtract it and then multiply the 4 out. So just kind of keeping that in mind. But I'm going to go ahead and find my 4 pieces of information. Number 1, what's the amplitude? Number 2, what is the period? Now keep in mind, this again freaks people out. This is 1/4 theta. So I can fit a quarter of the cosine graph in one lap around the unit circle, or in 2 pi, that's what that's saying, a quarter of the cosine graph. So I need to figure out how much it's going to take to fit a whole one. And if a fourth can be done in 2 pi, then all can be done in 8 pi. And the math behind that is 2 pi divided by that 1/4. We don't divide by a fraction, we flip and multiply, 8 pi. Good? Okay, so that's what's going on in our brain. Then I'm going to do my phase shift. I'm going to get lazy and I'm just going to do PS for phase shift. I hope that doesn't bother you. So my phase shift happens when theta over 4 plus pi over 3 equals 0. So I will subtract the pi over 3. And I will multiply by 4. And I didn't make it negative, so I'll go back in and fix my error. And then my vertical shift, none. Our D came at the end, but sometimes they're sneaky and they'll put the D at the beginning, and you'll know it's at the beginning because it will come before the amplitude. It'll say like 2 plus 1/2, blah, 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 and then it'll do the rest. But we'll get to that when we get to that. Okay, so I have a shift. My period is 8 pi. My shift is just a little more than pi, right, to the left. So I don't have to shift too much. So I am going to give myself room to the left. Then I'm going to do my standard 4 marks. This one ends at 8 pi, 4 pi. Cut that in half, 2 pi, 2, 4, 6, 8. Just counting my way through. 1/2, negative 1/2. This will mirror reflect backwards, negative 2 pi, negative 4 pi. I only need to put as much backwards as I'm going to shift, and because I'm only going to shift a little over 1 pi backwards, I really don't need to go even beyond negative 2 pi. And then I'll put my shift in there. And I'm not going to measure it. It doesn't have to be perfect. It has to be in the right region. By region, I mean in between the correct tick marks. And then my new axis, because this is in between these 2 tick marks, every new tick mark I make will also be in between. So I have one between negative 2 pi and 0, one between 0 and 2 pi, one between 2 pi and 4 pi, one between 4 pi and 6 pi, one between 6 pi and 8 pi. That gives me 1, 2, 3, 4 additional tick marks from my main axis. And then I can go ahead and graph the graph that I'm talking about. Again, I'm talking about cosine. So now my points are going to be on my new green tick marks. Again, that's why I show my axis in a different color. If I do it all in one color, sometimes it's like your eyes crossing, or I don't even know where it goes, because these get messy. But if I do it in a different color, I can tell the graph that I'm interested in. I sketch my cosine, and life is good. All right, let's do a shift with a sine. Go through my same process. In fact, I'm going to let you guys go through that process, and then we'll revisit in a little bit. See how you do. If you feel ambitious, you can even start to sketch the graph. I always freeze it before I pause it, and then I can't see. Because I know there's always seems to be an issue when we are dealing with the fractions. So if I'm dividing out this 4, division is going to make it blend in with the denominator that's always there. If I'm multiplying, then it's going to cancel. So it's just going to blend in. I'm dividing it by 4, so that makes it 16 in the denominator. And then when I think of this size, I think of left almost how much? Half pi. Left almost half pi. Well, my period is pi over 2, which again means when I'm shifting almost pi over 2, I'm going to need to go all the way, all the way in the other direction. So I'm going to make sure I give myself plenty of movement room to the left, because I'm moving almost as much as the period is, but backwards. But I'm still going to label my original graph with my original period, pi over 2. Cut that in half, pi over 4. Cut that in half, pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. Or add pi over 8 plus pi over 4, 1/8 plus 1/4. Or do 3/4 times pi over 2. Whatever it is that you need to do to get that job done, that's what we label this with. Good? Then I'm going to go backwards, almost pi over 2, so it mirror reflects in the opposite direction. And I go ahead and put my amplitude on here. And this is my shift. So again, I have my new shifted axis starting between negative pi over 2 and negative 3 pi over 8. And so all of my tick marks that I'm going to use to graph are going to be in between each of the originals. And I need to make 4 new ones to graph my new sine. Sine starts at 0, goes up, back to 0, down, back to 0. And again, keep in mind, these graphs go on and on and on forever. And in fact, on Monday, we're going to graph over an interval, which means that you're going to, Monday or Tuesday, I don't know which one actually, where you're going to put more than one period of the graph on there. You're going to put multiple periods of the graph on there and then see what it looks like. All right? Okay, questions on this? Let's get into a vertical shift. I know we have this other sign here. Oh, we should do this other sign, shouldn't we? Because it's negative. We can do it quick. I want to do it because it's negative. I like to give the negatives a chance. All right, amplitude is what? 4. Period is what? 2 pi over 5. Not pretty, but that's all right. Phase shift is when 5 theta minus pi over 2 equals 0. So which way am I going to shift? To the right, in the positive direction. I'll add pi over 2. I'll divide by 5. Dividing by that 5 blends it into the denominator. I still don't have a vertical shift, so I don't need to address that yet. We'll do that next. Shifting to the right, so I don't need any room on the left. I'm shifting pi over 10. Yes. I'll show you the kind of math behind it. So if I am taking, we'll use these numbers, that's fine. So 5 theta equals pi over 2. So I would divide by 5, divide by 5. Well, this is a fraction already, and this makes it like a compound fraction. So what I'm going to do is I'm going to make it so that I have a numerator and the denominator on the top and on the bottom, right? And I don't divide by a fraction, I flip and multiply. So what's going to happen is this is going to be pi over 2 times 1 over 5 when I flip that over. So it just blends right into the denominator. Does that make sense? Okay. All right. So my original 1, 2, 3, 4. This is 2 pi over 5. All right, I'm testing your math skills. What's the halfway mark? Pi over 5. Beautiful. What's half of pi over 5? Pi over 10. What's pi over 10 plus pi over 5? 3 pi over 10. Great. I need to shift it pi over 10. Oh, that was nice. It shifts exactly to one of my intervals. So again, I take my green marker and I draw my shifted graph, and all of my new marks are on old marks. I just have to add one additional. Because this is negative sign, I'm going to go down instead of up first. So I start at 0, down, middle, up, and finish off my sine graph. Remember, these aren't teeth, they aren't fangs, they're not pointy, they're nice curves. Sine and cosine are gentle, they're nice. Let's do the vertical shift. The vertical shift, I always think, is the one thing that is the most important to put on first, because it doesn't just shift your thing left or right. We're now shifting up or down. And so I've got to make room for my amplitude from my new center vertically. So I'll go through the same process that I did before. I don't like this -1 here in front, because a lot of times it looks like, hey, I should just do -2 plus 1 or -1 plus 2, sorry, and I get 1, and then no, it doesn't work that way. This guy here can just be moved to the back, so it's -1 on the end. So I take that away from there. I rewrite this as y equals 2 sine 3 theta minus pi over 4 minus 1. So if you ever see kind of this number floating in front by itself, that's your vertical shift. Move it to the back. Go through the same process. My amplitude, my period, phase shift, vertical shift. Amplitude is 2. Period is 2 pi over 3. Phase shift is 3 theta minus pi over 4 equals 0. So 3 theta is pi over 4. So theta is pi over 12. Nice job. Vertical shift, -1. That means I'm going to move this whole thing down 1 unit. My amplitude has to go off of my center. So when I move my vertical center, my amplitude gets counted from that location. Okay? It doesn't go up to 2 and down to -2 on the graph. It goes 2 above the center and 2 below the center. So when I graph this, my shift is to the right. Yep, to the right. So I did give myself good. My new vertical axis is down 1. That's at -1. My amplitude is going to go 2 above -1. And I always kind of give myself a cap so I don't go above that spot. And so that's at +1. And 2 below -1, which makes me bottom out at -3. So again, bless you, don't put your amplitude in until you get your vertical shift in. Sometimes your vertical shift is going to be so low or so high that your graph won't even go above or across the x-axis. Okay? So you've got to get that in and then take your amplitude from there. So I've got that in. Now I need to go in back and do that period on I'm going to do it on the original graph, and then I'll take my shift from there. So this is 2 pi over 3, pi over 3, pi over 6, brings me to pi over 2 on that last one. My shift is pi over 12. So pi over 12 is between 0 and pi over 6. And then all of my new tick marks are going to be between the originals with one additional to make up for the shift. This is a regular sine. Again, look at kind of a mess. But if I keep that new shifted axis visible, and if I give myself a top out and bottom out region, I can really see where the points need to go, and I can sketch my graph. And the last one, I'm going to, again, pause, and I'm going to let you guys give this one a try. Okay, put your new shift on there, give it a try, see how you do, and then we'll look, check our results. Come on. But that is my final result for my shift cosine.